Welcome viewers. In this video, we'll see the solved problem based on the sinusoidal response of RL circuit. Subscribe the channel for more videos and notifications. Soft copy of this material available in the drive. The link is given in the description box. Now we'll go to the topic. In the network given, find the transient current. So this is the RL circuit available. Resistor and inductor connected in series, 10 ohm and 0.1 Henry. It is excited by the sinusoidal waveform, 100 sin 10 sin 100 t. So voltage source applied. This is the current, transient current I of t. We need to find the expression for this transient current. So in the time domain, the equation for the above circuit based on the Kirchhoff's voltage law, the applied voltage equal to resistive drop plus inductive drop. Voltage rise equal to voltage drop. So R into I plus L di by dt equal to E. Now we'll substitute the value here. So R is 10 ohm, 10 I plus inductor is 0.1 di by dt. Applied voltage is 100 sin 10 sin 100 t. Right. Our aim is to find the transient current. So first we will find the Laplace. We'll take the Laplace transform on both the sides so that the t domain will be converted into s domain. After simplification, we need to take inverse Laplace so that again we'll get the t domain. So take Laplace transform on both the sides. 10 is constant. The Laplace of I is I of s. 0.1 is constant. The Laplace of di by dt is s into I of s. That is equal to 10 sin 100 t. Laplace of sin 100 t is 100 divided by s square plus 100 square. That is nothing but this omega divided by, the formula is omega divided by s square plus omega square. Here omega value is 100. So 100 divided by s square plus 100 square. So take this I of s common. So 10 plus 0.1 s equal to is 10 into 100, 1000 divided by s square plus 100 square. Right. Now we'll bring this term in the denominator on that side. So that 1000 divided by s square plus 100 square into 0.1 s plus 10. Now we'll go for the further simplification. So we need in the form s plus, so that this 0.1 is taken outside. Then only we'll get s plus. So 0.1 is taken outside, s plus 10 divided by 0.1. This 0.1 not available here. So 10 divided by 0.1 is 100. So we'll take this equation number 1. 10,000, right? This 0.1. 1000 divided by 0.1 become 10,000. Divided by s square plus 100 square into s plus 100. Right. Now we need to take the inverse Laplace, but we need to convert into standard form. Then only we can take the inverse Laplace. So this term is written as partial expression technique. The above expression can be written as a divided by s plus 100 plus bs plus c divided by s square plus 100 square. Right. Here only s is there. So only one constant a. Here s square is there. So two constant bs plus c. So this equation 1, by using partial expression technique, it is written like that. This one can be, we can easily take the inverse Laplace, but we need to find the value of a, b and c. Now we'll go for the further simplification. So this is equation 1 that is written in the partial fraction technique. So both are same. Now we'll take the LCM on both sides. We'll taking LCM on both sides. This term is multiplied with a. This term is multiplied with bs plus c, because here only one term is available. So a into s square plus 100 square multiplied. A plus bs plus c into s plus 100. Now these two terms available on both the sides, so it is cancelled. So 10,000 equal to a of s square plus 100 square plus bs plus c into s plus 100. I will take this equation number 2. So the next aim is we need to find the value of a, b and c. So we need to substitute the s value such that any one term got cancelled, so that we are able to find the remaining terms. So if you put s equal to minus 100, what happened? This term become 0. So we need to decide the s value such that it will equate to 0. If you put s equal to minus 100, this time is 0. Now we'll see what happen if you substitute s equal to 100, minus 100. So 10,000 equal to a of minus 100 square. S square is minus, s is minus 100 plus 100 square plus bs plus c into minus 100 plus 100. So this is nothing but bs plus c, right? Not only b, bs plus c. So the total term is 0. This term is 0. So here also it is 0. So only here minus 100 square is 10,000. Already here 100 square 10,000. So totally 20,000. 10,000 equal to 20,000 a. So a equal to 10,000 by 20,000, it is 0.5. So now we calculated the value of 0.5. So b and c we can calculate by equating the coefficient. Equating the coefficient on both the sides. Now we'll consider this equation 2. We'll simplify this equation and then we can equate the coefficient of s and s square. So this is the equation 2. 10,000 equal to a s square plus 100 square plus bs plus c into s plus 100. You multiply inside. 10,000 equal to a s square plus a into 100 square. Similarly here bs into s, so bs square, bs into 100, so 100 bs, c into s, c into 100. So now we'll take the s square coefficient, s square outside. So here s square is there a, here s square is b, so a plus b. Take s outside, here s is there, so 100b, here one s is there, c, right? The s is taken outside, so 100b plus c. This 100 square is 10,000, 10,000 a plus here 100 is there, 100 c. These two are constant. So this is coefficient of s square, a plus b. This is coefficient of s, 100b plus c. This is constant. Now we equate the coefficient of s square. S square is a plus b. Here s square term is not available. So a plus b is 0. So that b equal to minus a. A already we calculated 0.5. So b equal to minus 0.5. Similarly equating the coefficient of s, 100b plus c. So here s coefficient is not available. So 100b plus c equal to 0. So c equal to minus 100b. So minus 100 into b is nothing but minus 0.5. So minus 100 into minus 0.5 is 50. So now we calculate the value of a, b as well as c. A is 0.5, b is minus 0.5, c is 50. Now we'll go for the further simplification. So this is the equation 1. In that a value is substituted 0.5, b value is minus 0.5, c value is 50. Now we'll split the term. Here two terms are split it. So minus 0.5 s divided by s square plus 100 square. 50 divided by s square plus 100 square. See the now three terms available. This is rewritten. 0.5 divided by s plus 100 minus 0.5 s divided by s square plus 100 square plus 50 divided by s square plus 100 square. Here multiplied by 100 and divided by 100 in order to bring the standard form. So that what is available here after multiplying 100. So 0.5 divided by s plus 100, same thing. Here it is rewritten like this. 50 divided by 100 is written. 100 divided by s square plus 100 square. So that we can take the inverse Laplace easily. Right. Now, so only thing we have multiplied and divided by 100 and rearranged. So the Laplace, inverse Laplace of this 0.5 is constant. 1 divided by s plus a is nothing but e power minus at. Based on that, e power minus 100t. This a is 100. Right. So it is based on e power minus at equal to 1 divided by s plus a. A is 100. This s divided by s square plus 100 square is cos 100t. Here omega is 100 cos omega. Similarly 100 divided by s square plus 100 square is sin 100t. These two are direct formulas. That is, S divided by S square plus omega square is cos omega t. Omega divided by S square plus omega is sin omega t. Here omega is 100. Now this 0.5 is available commonly taken outside. E power minus 100t minus cos 100t plus sin 100t. So this is the expression for current, transient current. So in this video we discussed the solved problem based on the RL circuits, RL series circuit excited by sinusoidal wave. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.